Hello everyone, welcome to my YouTube channel Zenith GATE Mechanical. Continuation with the concept and question series. So in the first session, I talked about the Lami's theorem concept and we have solved some problem. So in the today's session, I will talk about how to do the analysis of coplanar force system. But before that, I just want to give a brief introduction of what is the force, what are the basic characteristics of force, then we will move to the analysis of coplanar force system. So the force is nothing but it is the action of one body on the other body which tends to change the body state of body. Force is nothing but the action of one body on the other body which try to change the state of body. So it is not necessary the state of the body will change. So what is the tense meaning here? Tense is nothing but it means not necessary, not necessarily changing the state of body, but it has the capacity and tendency to change and tendency to change. That means suppose if a body which is in the rest condition, if you will apply the force, the body will changing its state from rest to motion, or if the body is in motion, if you apply the force, then the body will come into the rest position. Okay. So this is the general perception of force, but it is not necessarily the force will change the state of that body. What it means, let's try to understood with example. Let us suppose this is a block which is resting over this surface. Now, this is the initial condition. Let us suppose the first position. Now, once you will apply the force over this particular block, what will happen? This body will come into the motion. That means I'm not bothering about what is the friction force which is exerting here. So if you are applying the force, the body will change the state from rest to motion. So let us suppose at some instant, the position will be. So this is the second position. So you have applied some force, the body is in the motion. Now in the second case, let us suppose that initially the body is in motion. The body is in motion. So at this state, the body is in motion. So you have applied some force. You have applied some force. So the body is coming into the rest position. Because of this F force, the body is in moving in this direction. Now, once you have applied the forces, let us suppose the body is coming to the rest. It means the force is trying to change the state of a body from rest to motion or from motion to rest. But it is not always necessarily that it will change the state of body. For example, let us suppose there is a frame which is attached at this particular end. Okay, so this will be the fixed. Now, if a person is applying some force over this frame, so this is nothing but one body. I'm assuming this is the second. So force exerted by 1 on 2 is nothing but F12, which is equal to F21. By using Newton's third law, force is equal in magnitude but opposite in direction. So whatever the force which will experience by this man due to this frame, which will be equal to the force experiences by this frame due to this particular man. Okay, so in this particular case, if you see, the body is not in the motion, it is in the rest condition. So it is not necessarily it will change the state of body, but it has a capacity which can change the state of that body. The body can be moved from rest to motion or from motion to rest. Okay, so I have talked about the forces. Now try to understand what are the characteristics of force. That means how you will define the force completely. So characteristics of forces. As you know that the force is a vector quantity. Force is a vector quantity. Vector quantity. That means the vector quantities are those which is having a magnitude and direction. Which is having a magnitude and the direction. And the direction. Now, is these two characteristics are sufficient to define the force completely? The answer is no. Why? Let us suppose one example. There is a beam which is fixed at this particular end. Now I am applying some particular force at the end which is equal to 10 kilonewton. So second case, this is the case number 1. Okay, so I'm assuming the length of beam is L. Now the second case is there is a again the same beam. Now the force is acting at this point whose magnitude is same 10 kilonewton and the direction is also in downward direction. Okay, so in both the cases, if you see the magnitude and the direction are same, but the effect will be different. But the effect of these forces is different. Effect is different. Because if you take the moment about this point, the force into this distance, and let us suppose this force is acting at a distance of L by 2. So the moment will be F into L by 2 at this point, and here the moment is F into L. So even the force having the same magnitude and the direction is same, but the effect is different. That means the point of application is also play a very important role. So the third point is nothing but the point of application. Point of application. Point of application. Now come to the characteristics again. Is these three important parameter are sufficient to define the force completely? That means the answer is again no. One more things you have to consider to define this force, which is nothing but the line of action. The line of action. What it means? For example, there is a rectangular plate. There is a rectangular plate which is resting over this surface. Okay, which is resting over this surface. Now, if you are applying some force, and this force is passing through this center of mass of this plate. So this force is 10 kilonewton. So what will happen to this rectangular plate? It will translate in this direction. Okay. But if the same force, if I will apply along this line of action, that means if the force is not passing through the center of this mass, so in that case, the effect will be different. So in this case, the body is in the translation condition. Now, if I will apply the force in the second case, this is case number 1. If the force is acting at this edge or this corner. So let us suppose the same force, 10 kilonewton, which I am applying. Then what will happen to this particular body? So in the first case, the body is in the translation, but this force having both translation and the rotational effect. So, or it will try to, this body will translate in this direction as well as try to rotate also. Okay, so in this particular case, the body having a tendency, the force having both translation plus rotation effect. Rotation effect. That means these four parameter you have to consider to define the force completely. One is the force. You have to define what is the magnitude, what is the direction, and where this force is acting, which is nothing but the point of application, and along which line it is acting, which is called as a line of action. Okay, so now comes to the coplanar force system. So coplanar force system means when all these forces are lying in the same plane. Okay, so first point for a coplanar, and concurrent force system, concurrent force system, coplanar and concurrent force system. What is the condition? The summation of force in x direction 0 and summation of force in y direction 0. You can use these two conditions for solving the problem. Okay, if only three forces are acting, you can do the same problem with the Lami's theorem also. If more than three forces are acting, then you can use summation of force in x direction 0, summation of force in y direction 0. And this is the generalized approach. Okay, so let us suppose this is a body. Okay, now the forces are acting. Let us suppose this is the F2 force, this is the F1 force, this is the F3, and this will be the F. Okay, now if you see all these forces are lying in the same plane means let us suppose this is the x-axis and this is the y-axis. So the plane is xy plane and they are passing through the same point, which is nothing but O. Now you can use these two equations for solving these problems. But when the concurrent is not mentioned, only coplanar force system, then you have to use one more equation, which is nothing but moment, summation of moment equal to 0. So the second point is for a coplanar force system, the necessary and the sufficient condition for the equilibrium is summation of force in x direction 0, summation of force in y direction 0, and summation of moment about any point will be equal to 0. Okay, so these three conditions are sufficient for solving the coplanar force system. I hope this series truly help you in your exam preparation. So don't forget to like, share, and subscribe. Thank you so much.